So you may remember in my last video, I looked at my remeasurement error magnitude. And I decided to expand that some time ago and do a little pilot study involving some first-year students at St. Francis. And Nicole Nelson gave me the opportunity to talk to her class. And this is basically the pitch I gave them, that I was looking for volunteers to come in and measure some mollusk shells. And it would take each person roughly 2 hours to do it. I decided I was willing to do this 4 different days in October, so different days of the week that were convenient for me and hopefully for them. And I had set aside 3 2-hour slots on each of those days, and I figured I could do about 3 students per slot. We sweetened the pot a little bit by offering that this would count towards some of their service engagement, which is a requirement for the course. And that service engagement is supposed to be hours spent helping the community, and we frame this as being a service to the scientific community. So I created a sign-up site where they could just log on and put their name down for one of the available slots. And as you can see here, I had a total of 36 available opportunities. 8 students actually scheduled, and only 4 of them completed the study. So during each of those sessions, I'd start off by sitting down with at a table with them in one of the labs, each of us having a set of calipers that were all identical in make and model. And I started off by having them follow me through the steps of using the calipers so they knew mechanically how it worked. And then I had them, each student measure 4 different American coins of different denominations, different sizes, and I had them do the diameter and the thickness. And then once they were good at that, we went through how to measure the length, the height, and the width of a mussel shell. So I had a shell in my hand that was not part of the group that they were going to be measuring, and each student would go ahead and measure one of their shells while I was sitting there with them. Once they got comfortable with that, I'd sort of wander away to a different part of the lab so I wasn't hovering, and then I would had them fill out the data sheet on paper with their measurements. Well, once they finished, I had previously sent to them a blank data sheet that they'd fill out and then email back to me with their electronic data. And that helped me to kind of streamline things a bit, so I didn't have to enter all that data, and it also took away sometimes the handwriting issue. It's worth saying a little bit about the shells that I provided them. They were all originally collected at Crooked Lake, and they were all Lampsilis siliquoidea. And since they were museum specimens, they all had ID numbers written on the inside of the valves in India ink, so that helped identify which was which, and if they got in the wrong back in the wrong envelope, they could easily be reassigned. And they were what I would consider to be relatively large specimens for medium to large specimens for this locality, ranging in length from about 67 to around 90 millimeters. So they were originally from what I would consider to be adult specimens at Crooked Lake. So this is what I wound up getting from each of the 4 students. I've removed the name here for privacy purposes. I had them record which set of calipers they used by letter. And then here's the top. On this top, you can see where they've entered their thickness and diameter measurement for a dime, a penny, a nickel, and a quarter. And then the lower section are the measurements of the length, the height, and the width for each of many individual mussels. So the ID numbers are over here in the left-hand column, and then the lengths and height and width in the other. And in summary, if we want to just look quickly at the measurements of the money, summarized here, the diameter and the thickness measurements. So to refresh your memory, I'll go through this a little bit on using the method that Downing and Downing used on their freshwater mussel measurements, and as I did in the last video. So the way this worked was, I took found the mean value of all 4 measurements from each of the students. By the way, their names are removed here for privacy, so I'm just calling them A, B, C, and D. So I take the average of these measurements here to find the mean, and then to get the remeasurement errors, I subtract the individual measurement for the dime for student A from the average, 17.8, and that gives me this remeasurement error of minus 0.10. So for all the, here's the remeasurement errors for the diameter, and here's the remeasurement errors for thickness. And to summarize that, I'll put it in this little table here. There were too few data for me to do a 95% range of remeasurement errors, so I just did all of them from top to bottom when they were sorted. And so those 4 students had a range of remeasurement errors of diameters between minus 0.63 and positive 0.30. And when you take those and you find the difference, what I'm going to call the spread of those values is just shy of 1 millimeter, 0.93. The same kind of thing goes for their thickness measurements. So you may recall from a previous video where I looked at my remeasurement errors for length, the 95% remeasurement error for me ranged from minus 0.27 to positive 0.23. The students had a wider spread, so theirs went from minus 1.63 to positive 2.73. And when we put that in a table, so you can kind of compare apples to apples, the spreads here, mine was half a millimeter, their spread was 4.36. And that's a little over 8 times the amount of variation that I had. So, and of course we measure 2 other dimensions. We do the height. In my little study where I looked at only my variation, it ranged from minus 0.37 to 0.80. The students' values were quite a bit more spread out, from minus 6.08 millimeters to positive 14.58 millimeters. And again, my variation for with remeasurement errors ranged from minus 0.17 to positive 0.20. The students with remeasurement errors went from minus 4.40 to a whopping 10.43. So I've summarized all that in a little table here, and also included so everybody can remember what Downing and Downing did with shell height. And again, when we look at length, my spread was considerably less than the students. And you may recall, I felt pretty good about myself that my spread, looking at height, compared favorably to that reported by Downing and Downing for their siliquoidea. Of course, what we're interested in here is how my values compare to that of the students, and their remeasurement errors were a little over 17 times greater than those that I had. And when we compare my widths to their widths, it was even more extreme. Their remeasurement errors were 14.83. Mine were only 0.37, and that's a 40-fold difference in magnitude. Another way we can slice this up is by comparing length, height, and width to one another. When I did this before, what I found was that the least amount of wiggle in my measurements, my remeasurements, was in terms of width. So I only had about 0.37 millimeters of wiggle when it came to measuring width. Length was, as I said before, around 0.5 millimeter, so that came in kind of second place. And then the most amount of variation was when I tried to remeasure height, and that was 1.17. Yeah. Well, how did the students do? They seem to have the least amount of trouble getting agreement when they were measuring length. So only 4.36. Width kind of came in second at 14.83, and the most amount of difficulty or wiggle in their data looked like height. So a little bit different pattern than we saw with my remeasurement errors. Well, what's that variation look like in the context of how large the individual mussels are? And as you'll recall, I gave you a range of size, approximately 67 to 90 millimeters long was the group of shells that were measured. And the mid-range of that, halfway between 67 and 90, is 78.5. So if we take, using my numbers for a minute, if we take the spread for 95% range of measurement errors that I came up with, which was 0.5 millimeter, and we put that on the top of the fraction, and then we use the mid-range for the sort of known size of the group of 78.5, we get a value of a lot less than a tenth of a percentage point. So pretty good for the size of shells. My measurements of shell length are pretty spot on. If we do the same thing with the students' numbers, they had a spread of 4.36 for length, and divide that by that 78.5, we get a little bit north of 5%. So I was bragging a little bit about how well I did, and theirs is, as you might expect, quite a bit higher, but still not too bad. Pretty reasonable, I think. Well, what have we learned or what have I learned from this little pilot study? First of all, it's really hard to get people to participate in stuff like this. I had, 4 people out of a class of about 40 that actually completed the study, so that's about 10%. Experience does seem to matter. Evidently, I haven't really completely squandered the last 2-3 decades of my life. I've done other things, of course, too, but having done this for a while does seem to give a guy a bit of an edge on reproducibility of measurements. And despite the differences that appear in variability due to experience, the pattern does seem to be similar in that it seems to be harder for humans to measure the shell height than it is the other 2 dimensions. Now, the pattern is a little bit different for me and the students, but in both cases, the variability for the shell height was the greatest. So moving forward, here's some of the stuff I'd like to do. One is to attract more people to this, to my next incarnation of this project. I'd like to get about 30, which would mean, if past is an indication of future, I'd need a pool of maybe 300 people to solicit to do this. And that would entail at St. Francis going outside of the sciences. So, I can envision sending out some kind of a plea to other instructors across campus and different disciplines to see if I can get them to send students my way. Another avenue that I'd like to pursue would be to get some of my former folks, former students, and former colleagues that participate in my mussel roundups to do this. And some of these folks have been at this for a number of years, more than 10 or 15 years. So there's quite a bit of experience I could tap beyond my own. And then thirdly, I'd like to have each participant measure each shell 3 times, kind of like I did in the previous episode of this video. So that way I'd be able to get not only at the variation between researchers, like I did in this little pilot study, but I'd also be able to look at what some disciplines would call intra-rater reliability. So how well does an individual do it, and then how well do different individuals do it in agreement with one another. So those are some ideas for the future. Well, thanks again for spending roughly 20 minutes of your life with me. I appreciate any comments you might have. I'm hoping to boil this down into a shorter, more succinct presentation in order to present it to some colleagues at an upcoming conference. Okay, so in any case, hopefully in the next week or 2 you can tune in for another episode of Crooked Lakes Mussels. Thanks again for watching. Bye.